Here's the video for page 7 of transformations. First of all, we're going to go back and look at the investigation function. Remember, the investigation function has the a value, the b value appears in 2 places, c value appears in 2 places, and the d value. Okay, and we talked about what each one of these does. Remember, the a values and the b values, since they're multiplication, are related to stretching, compressing. Okay, and remember that the outside the parentheses, it's going to be vertical, and inside the parentheses, it's going to be horizontal. Okay, so A is vertical and B is horizontal. Okay, and so remember that when A became a bigger value, then that was a stretch as opposed to a compression. Okay, so when A was smaller, closer to 0, then it was a compression. Okay, and B, since it's inside the parentheses, behaved in the opposite way. And so when B became bigger, it was a compression. Okay, and then when B was smaller, then it was a stretch. Okay, so remember, when things are inside the parentheses, like B and C, things behave kind of the opposite way as what you would expect. I call it bizarre world. Okay, all right. So keeping that in mind, let's go down to number 1. We're going to do A, C, and E. So sketch on the same axes a set of graphs, f of x, 2f of x, and 3f of x. So since the 2 and the 3 are outside the function, that means it's a vertical. And so if it's outside, also it's going to be stretch when A is bigger. So 2 and 3 are bigger than 1, so they're going to stretch it. Okay, so first thing I'm going to do is I'm going to draw the axes. And then I'm going to use blue to draw the original function. Blue to draw the original function. And then I'm going to use yellow to do 2f of x, and then I'll use green to do 3f of x. Okay, so blue is going to be the parabola, parent function. And then yellow is going to be the parabola stretched by a factor of 2. So what does that mean? That means that the vertex stays where it was. The points that are 1 unit away from the x-axis are going to be 2 units away from the x-axis. And the points that are 4 units away from the x-axis are going to be 8 units away from the x-axis. So it looks something like this. And then the green is going to represent 3f of x. So that means that the vertex is in the same place. And then the point that is 1 unit away becomes 3 units away, and so on. Something like that. Okay? And now I'm going to do e to the x. Okay, so e to the x, I'm just going to draw the axes for e to the x. Put it there. So remember, e to the x, the points that we know how to graph without the calculator are 0, 1, because when you put 0 into e to the x, it's e to the 0, which is 1. And then if you put 1 into e to the x, if x equals 1, you get 2.7. So, and then of course, there's an asymptote at 0. Okay, so it looks kind of like that. And then the 2e to the x, would just make every single point 2 times as far from the x-axis, something like that. Okay, so instead of crossing the y-axis at 1, it's going to cross it at 2. Okay, and then 3e to the x, it would be the y-intercept, it would be at 3 instead of 2. And then instead of crossing at 2 times 2.7, it would be 3 times 2.7, which would be something like, I don't know, 7.5 or something like that. 2, 4, 6, 8. It'd be like somewhere around there, I think. Okay. All right. That's not a very good graph, but okay. Now let's do 1 over x. 1 over x. So 1 over x. Oops, I shouldn't put it there. Let's see, 1 over x. So, okay, so the original function, we're pretty experienced at drawing it now. Looks kind of like that. And then the function 2 over x, the yellow function, is going to be twice as far from the x-axis. And then the green function, 3 over x, is going to be 3 times as far. You can just like graph like one point, an easy to graph point, like -1, -3, and 1, 3, and then it's, the rest of it, it's just a sketch. Okay. If you had a calculator, you could get a lot more points. If you had a lot more time, you could get a lot of points. But that's good enough for now. Okay. All right. Now let's do the opposite. Now what we're going to do is we're going to graph vertical compressions. Right. So let's see. So the first function I'm going to do is x squared. Oops, yeah, it doesn't matter what color the axes are. Okay, so the regular parent function looks like this, right? Okay, and then the function 1/2 x squared is going to be a vertical compression, so all the points are half as far from the x-axis as before. So actually this one would be 9 divided by 2, which would be 4.5. Okay, and then the next one would be 1/4 x squared. So 1/4 x squared, every point will be 1/4 as far from the x-axis. So this is going to be here. So like since the original blue point is 4 away, then the green point is going to be 1 away. And this would be about 2.5. Something like that. Okay, so it's a shorter function. Okay. All right. And let's do e to the x. Okay, so e to the x, it crosses at 0, 1. And let's see, what is 2.7? So 2.7 squared is like 7 something. 4, 6, something like that. Okay. All right. Now I'm going to draw the function 1/2 e to the x. So this would be half as far, and this, instead of being 7, will be like 3.5, and this would be like 1.3. Okay, and then last of all, I'm going to do 1/4 e to the x. So instead of 2.7, it's going to be like less than 1. Instead of 7, it's going to be like less than 2. Something like that. Okay? All right. And let's go down to number 3. So for this one, I am going to do the original function in blue, and then I am going to do what would this be? This would be a horizontal, because it's inside the parentheses, compression, because the two, when you have a bigger number than 1, then you're going to do a compression instead of a stretch. Okay, so let's draw first y equals x squared. One, two, three, 4, 5, 6, 7, 8, 9. Okay, and then I'm going to do a horizontal compression by a factor of 2. So everything is going to be half as far as before from the y-axis. Okay, so like this, for example, is 2 units away, so it's going to be 1 unit away. This is 1 unit away, so it's going to be half a unit away, and the vertex is going to stay in the same place. This is 3 units away, so I'm going to make it 1.5 units away. Okay, so it's a narrow parabola. Okay, now let's do this function here. So this function is a parabola which has a vertex at -3, 0, right? If you put it in HK form. So let's see, the vertex is here. There's my initial function. Okay, it's a parabola that's centered at -3, 0. And then I'm going to do a horizontal compression by a factor of 2. And the reason why this one is kind of different is before it was kind of easy to see what the center of the compression was because the thing was centered on the y-axis. Now remember, when you do the compression, the part of the parabola that doesn't change position is the part that's on the y-axis. So this point here is going to stay in the same place. But every other point is going to be half as far as it was before. So it's going to look kind of like, let's see, 1, 2, 3, like that, right? So like this point, which was 6 away, is going to be 3 away. This point, which was 5 away, is going to be 2.5 away. Okay? So you see the shape of this one is the same as this one, but the center is off, right? So like the center actually moved. The vertex actually moved because the vertex was not on the y-axis. So when you did the horizontal compression, the vertex moved because it's not on the axis. When it's on the axis, it's not going to move when you do the horizontal compression. But when it is not on the axis, if it's 3 units away, now it's going to be 1.5 units away. So that's a little tricky. Where is the axis or the anchor when you do your compressions and your stretches? Okay, so let's do page 8. So number 4, sketch on the same set of axes the graphs of y equals f of x and y equals f of x over 2. So remember, inside the parentheses, it's Bizaho world. So when you multiply by 1/2, it's a stretch, right? So I'm going to stretch by a factor of 2, okay, in horizontal direction. Okay, so let's do that. So first we're going to do y equals x squared in blue, and then we're going to do x over 2 in yellow, okay? And it's actually going to be a horizontal stretch. Come on. I'm not very good at doing this yet. Okay, so y equals x squared looks like this. Oops. Something like that. And then I'm going to do a horizontal stretch by a factor of 2. So the things that were 1 unit away are now going to be 2 units away. The things that were 2 units away are now going to be 4 units away. Okay? All right. And now let's do this one. So this one is a parabola that has its vertex at negative 2 comma 0, right? So the original parabola looks like this. And then the stretched parabola in the horizontal direction, remember, the anchor point is the point that is on the axis, on the y-axis. This point is not going to move. All the other points are going to move to be twice as far away as the original point. 1, 2, 3, 4. So this is going to be 8 units away. 1, 2, 3. 1, 2. Well, because 1, 2, 3. 1, 2, 3. Okay. Okay, like that. Okay, so do you see the point that doesn't move is the one on the y-axis? All right. Okay, let's go to number 5. So number 5, I'm going to do A and C. So I'm going to do y equals x. That's an easy graph. It's just a diagonal line, right? Y equals x is this line here. And this time I'm going to do a horizontal. Is it going to be a stretch or compression? So 3 is bigger than 1. It's Bizaho world. So instead of getting wider by 3, it's going to get narrower by 3. So it's going to be like a 1/3 stretch by a factor of 1/3 or a compression by a factor of 3. So instead of being 3 units away, it's going to be 1 unit away. Right? Instead of being 6 units away, it's going to be 3 units away. Oops. 2 instead of 3 units, instead of 6 units away, it's going to be 2 units away. Okay, so something like that. Okay, let's do y equals e over x. Y equals e to the x. Okay, so e to the x looks 2, 3, 4, 5, 6, 7. Kind of like that. And then the function that is a compression by a factor of 3 this is going to be hard to draw because my exponential drawings are like not good anyway. So yeah, it's going to be very steep, something like that. Okay. All right. And let's go to number 6. Consider the function. This is just this notation here. It just means f of x equals x squared. And sometimes IB is going to use this notation. Don't let this scare you. It's just f of x equals x squared. That's it. Okay, and we're going to do A and C. So we are going to first draw the function y equals blah, blah, blah. And then, we're doing it for x squared, right? We're going to first draw this function on the left, which is quite complex, right? It's got this it's got this, and it's got this. So the 3 multiply is going to be a vertical stretch by 3. The minus 2 inside the parentheses is going to move it to the right by 2. And the plus 1 on the outside is going to move it up by 1, right? And then after we do that one, we're going to do this one, which has other characteristics. Okay, so I'm going to draw the parent function like that, and then oh, that was my parent function. So for this function, I'm going to do it in yellow. Okay, so what order do you do it in? Well, sometimes it doesn't really matter what order you do it in, but start from inside the parentheses. Okay, start from inside the parentheses because it's kind of PEMDAS order. So we'll start here with the horizontal, and then we'll do the 3, and then we'll do the 1. Okay, so first we'll do minus 2. Remember what minus 2 does. Minus 2 moves it to the right by 2. So I'm going to move it to the right by 2. Okay, so it would be kind of like that. I've zoomed in here to do the next step. So now what we're going to do is we're going to move it, let's see, we're going to do the next thing in PEMDAS order, which is to stretch it vertically by a factor of 3. So, so this is going to stay here, and then this is height 1, so it's going to be height 3. Height 1 is going to become height 3. Height 4 is going to be height 12, so it's going to be way off, right? So now it's very stretched. Okay, and then finally, the last step is we're going to add 1. I'm going to add 1. And so it's going to be a vertical translation up, right? So now this point here is going to move up to here. This point here is going to move up to here. All the points are going to move up 1. Okay, so here's your final function. The vertex is here, and it's been stretched, and it's moved up 1. Okay, so that is this one here. Okay, now let's do this one here. And I said, it's like I could do it on the same axis, but it's going to be a mess, so I'm going to do it on another axis. So now let's do this one here. So what we're going to do is we're going to start with the same parent function. Okay, there's the parent function. And then we're going to do this in PEMDAS order. So the first thing we're going to do is we're going to move it to the right. Oh, we're going to move it to the left by 1 because it's plus 1, right? So we're going to move it to the left by 1. Okay, and then we're going to do the next thing in PEMDAS order, which is going to be, we're going to do a vertical stretch by 2. Let's see, let me do like okay, vertical stretch by 2. So that means that the vertex stays here, and then the points that were 1 away from the x-axis are going to be 2 away, and then these are going to be much farther away. Okay, so there I did a vertical stretch by 2. The next thing we do in PEMDAS order is we do minus 3. And minus 3 is going to make it go down by 3, right? Go down 3 units. So the vertex is now going to be here. The other 2 points are going to be here. And then I don't even know where these points are because I didn't graph them. And, these are like 3. Something like that. Okay? All right, so we did this one. That was quite challenging, wasn't it? Okay, so I would try to do these problems, if you didn't get it the first time, more than once to understand the step-by-step nature, which one you do first, follow PEMDAS order. If you want to try to do it in the wrong order to see what happens, depending on which order you invert, you get the wrong answer. Okay, so let's do part B. Now for part B, I'm gonna do let's see, 1, 2, 3, 4 steps, and I'm gonna do it in yellow, dirty yellow, orange, and then red. And I'm doing it in PEMDAS order, except you might notice that, do you see how like here's x minus 3, and then I have x divided by 2 minus 3, and I'm doing the minus 3 before I'm doing the x over 2? Why am I doing it in the wrong order? Because again, this is Bizaho world. So inside the parentheses, everything is like the opposite, including PEMDAS order. So even though it looks like minus 3 should come afterwards because of PEMDAS, we actually do it first. So the translation to the right by 3 happens first. And remember, it's to the right, even though it's minus 3 because it's Bizaho world. And then the x divided by 2 is a stretch in the horizontal direction by a factor of 2, right? Dividing by 2 stretches in Bizaho world. Then we do a vertical stretch by 2, and then we do a vertical translation up by 4. And since we're outside the parentheses, it's normal world, so multiplying makes it bigger, and adding 4 makes it go up. Okay? All right, so I'm going to make this bigger. First, I'm going to do the regular parent function. And then I'm going to do the yellow step, which is I'm going to move it to the right by 3. So vertex moves here. The rest of the parabola looks like that. Okay, and then the next step is I'm going to do the horizontal stretch by 2. That's going to be dirty yellow. Horizontal stretch by 2. So remember, the vertex, which is 3 units away from the y-axis, becomes 6 units away. And the other 2, let's see, this is like 2 units away, so it's going to be 4 units away. And then this is 4 units away, so it's going to be 8 units away. And then some of these, this one's going to be here, and one of them's going to be off the screen. Okay. Okay, so there is my horizontal stretch by 2, and the orange is going to be vertical stretch by 2. Vertical stretch by 2. So the vertex stays where it is. The dirty yellow goes up from 1 to 2. It's going to be twice as far. This one is 4, so it's going to go up to 8. Okay, so that is the orange step. And the red step is I'm going to shift everything up by 4. One, two, three, 4. 1, 2, 3, 4. This is off the screen. Okay? All right, so that was B. Okay, why did I do B? Because these are really good problems, so I want to do them all. Okay? All right, last of all, let's do 6C. Okay. Oh, look at this one. For this one, they just gave it to us all in one step. But I'm gonna break it up into 4 steps, because we know that in order to do a problem like this, you need to break it up into 4 steps. Okay. So first, I'm going to do the plus 5, because in PEMDAS order, you're going to do the inside parentheses first, but this is inside Bizaho world, so the plus 5 you're going to do first, which means you're going to do left 5, right? And then we're going to do the 2x. The 2x in Bizaho world is going to be a horizontal compression by 2. So horizontal compression by 2. And then we're going to do the 1/4 multiply. which is going to be a vertical stretch by 1/4. It's going to be a compression, actually. And then finally, we're going to do +1, so that would be a vertical translation up, okay, by 1. Okay, so this will be a miracle if I do this and it doesn't go off the edge of the paper, all right? Looks like I should kind of do it. Oh, I'm gonna move to the left. So I think I should kind of put it over here. Okay. So the regular parabola looks like that. Okay, and I'm going to do a horizontal compression by 2. So, first I'm going to go left 5. 1, 2, 3, 4, 5. Okay, so first I do left 5. And then I'm going to do horizontal compression by 2. So let's see. I moved by 5, so this is going to be 2.5. And this is going to be horizontal compression by 2. So this is 3, something like that. So now it's very narrow. Okay, this doesn't look very orange. I wanted this to be kind of orange. Okay, vertical stretch by 1/4, which means that the thing is going to be like super small. Okay, something like that. Okay, and then finally, vertical translation up by 1. Okay, so first thing we did is we moved left by 5. So we went from the blue to this yellow here. Okay, oops. Sorry about that. I'm going to pay for that subscription this weekend, and then that thing won't pop up anymore. After the yellow, then I do a horizontal compression to dirty yellow, so that the horizontal compression is by a factor of 2. So this part here, which is, let's say 5 units, it's going to be 2.5 units. This part right here, which is 6 units, is going to become 3 units. This part here, which is, I don't know how many units, is okay, so everything's going to be half, all right? And then finally, we're going to do vertical stretch by 1/4. And so do you see how like the dirty yellow here is going to become this, it looks almost brown, it's supposed to be orange. It's going to be 1/4 as high as it used to be. Can't draw too many details now. And then finally, the vertical translation up by 1, the orange becomes oh, oops. The orange becomes the red one. Okay, and then the red one is the final one. Okay, all right. So that was, I think, the most challenging part of the unit, and I think it's even more challenging than what we do later. So it's important that you understand that well. Ask me questions if you need to. Okay, number 7. We're going to do 1 and 2. Okay, given that the following points lie on f of x, find the coordinates of each point that moves under the transformation y equals 3 f of x, parentheses 2x. So what is this doing? So remember, the PEMDAS order would be horizontal compression by 2, right? Because this is, what do you call it? Bizaho world. So multiplying by 2 makes it smaller by 2. And then after that, we do a vertical stretch by 3, factor of 3. Okay, so let's do these points undergoing this transformation. So when we do a horizontal compression, that only acts on the x-axis, on the x-coordinate. So the x-coordinate is 3. If we do a horizontal compression by a factor of 2, the 3 becomes 1.5, right? The -5 undergoes the vertical stretch by 3, and so the vertical stretch by 3 of -5 would make it go to -15, right? So that would be my new point, 1.5 comma -15. All right, let's do the same thing to 1 comma 2. So for 1 comma 2, the 1 undergoes a horizontal compression by a factor of 2, which means the 1 would become 0.5. And the 2 would undergo a vertical stretch by 2, so it would be 2 vertical stretch by factor of 3, so it would be 2 times 3, which is 6. Okay, so 0.5 comma 6 would be the new coordinates. Okay, now we're going to do the same thing, except now what we're going to do is these coordinates which have been given are the destination, and we're going to figure out what point moved to these destination points. So we're going to do the opposite. So instead of doing horizontal compression 2 and vertical stretch 3, we're going to do the opposite. We're going to do vertical compression 3, and then we're going to do horizontal stretch 2. Okay, so we're just going to do everything the opposite in the opposite order. Okay, so first thing we're going to do is we're going to do vertical compression 3. So the 1 is going to be vertically compressed by 3, which means it's going to become 1/3, right? And the 2 is going to undergo horizontal stretch by 2. So horizontal stretch by 2, the 2 is going to become a 4, right? And just to check it, you could do the transformation here to see if you get the same thing. So horizontal compression by 2, the 4 becomes a 2. Vertical stretch by 3, the 1/3 becomes 1. So it worked. Okay, let's do the next one. So -3. Okay, so first we're going to do the vertical compression. And in this case, you can see that if you did it in the wrong order, it's not going to matter in this particular case. Okay. So if we do vertical compression 3 first, the 2 is going to become 2/3, right? A vertical compression by a factor of 3. And then we're going to do a horizontal stretch by a factor of 2. So the -3 is going to become -6. If we want to check it, we can do this transformation here. So we do a horizontal compression by 2. So that the -6 would become -3. And the 2/3, we're going to do a vertical stretch by 3. So the 2/3 is going to become a 2. It worked. Okay. All right. That's it for page 8.